Okay, and for part B, if Lainey ran 930 meters, how far did Mason run? Use a tape diagram to demonstrate how you found the answer. So what I'm doing here is I'm just replicating my last tape diagram. I wish I would have just used a pencil like I did in the first one, but I'm just gonna quickly redraw it again, representing that 2-to-3 ratio, Mason to Lainey. Okay, we know that Lainey ran 930 meters. We don't know how many meters that Mason ran. But I do know that Lainey has 3 units. So I can take my total, 930, and divide it by the number of units. So I'm going to divide that by 3. Okay, another way to write this is like this. Okay, and this might be easier for a longer problem. Let me zoom in for a second here. So if I go ahead and do my division, 3 goes into 9 3 times. 3 goes into 3 1 time. Okay, so I get 310. So I know the value of each of these units here is 310. And the same goes for Mason's. So to calculate how much Mason has, I just 310 plus 310, which gives me 620 meters. What ratios can we say are equivalent to 2-to-3? So there's a unlimited number, but let's just make a little chart, 2-to-3. Okay, so I know that if I multiply, this is basically saying 2 units of whatever. So if each one was 2, I would multiply each of these numbers by 2. So 2 times 2 is 4, 3 times 2 is 6. So we've got 4 to 6. If I want to multiply each of them by 3, 2 times 3 is 6, 3 times 3 is 9. Okay, I also have multiply each one by 4. 2 times 4 is 8. 3 times 4 is 12. If I multiply each one by 5, 2 times 5 is 10. 3 times 5 is 15. Okay, so just making sure that you're multiplying each number in the ratio by the same number, that will give you an equivalent ratio. Just like when we had our tape diagram and we're changing the number that the value of each unit, that's what you're doing here by multiplying each number of the ratio by that same number. All right, and then our last exercise problem is exercise 4. Josie took a long multiple choice end of year vocabulary test. The ratio of the number of problems Josie got incorrect to the number of problems she got correct is 2-to-9. Okay, so I know I'm working with a ratio that is incorrect to correct, making sure the language is consistent, and I'm keeping that order, incorrect to correct. So I write incorrect first and then correct. 2 incorrect and 9 correct. Seven, 8. Gotta do one more. There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is representing a 2-to-9 ratio. If Josie missed, now I'm looking at part A. If Josie missed 8 questions, in other words, she got 8 incorrect, how many did she get correct? Draw a tape diagram to demonstrate how you found the answer. We know that the number of questions that the entire tape diagram for incorrect represents is 8. We see that there are 2 boxes here, so we take our 8, we divide it by 2, and that equals 4. So each of these has a value of 4. That means all down here, each box will have a value of 4. Okay, so how many correct? I know this is 9 groups of 4. 9 times 4 equals 36. So 36 questions correct. Okay, so now for part B, what I've done is I've just erased those numbers, but I've kept the foundation because we're working with equivalent fractions. The tape diagram itself will not change. B says, if Josie missed 20 questions, how many did she get correct? Okay, so same idea, but now there are 20 that she missed. In other words, 20 were incorrect. So we do that same process. I know 20 divided by 2 equals 10. So each box has a value of 10. Okay, and then down here I have 9 groups of 10. 9 times 10 equals 90. So she got 90 questions correct for part B. And part C says, what ratios can we say are equivalent to the ratio 2 to 9? So again, as long as we're multiplying both sides by the same number, we're going to get equivalent fractions. Just like when we changed the inside of the box here, we made sure that it was the same number on both. So if I multiply 2 times 2, I get 4. 9 times 2, I get 18. Okay, if I multiply both sides by, let's say, 3, 2 times 3 is 6. Oops. 9 times 3 is 27. So there's another equivalent ratio. If I multiply both sides by 10, which is what I just did here in this problem, 2 times 10 is 20. 9 times 10 is 90. Just like we got in this problem where each square had a value of 10. That's all we're doing is multiplying the original ratio by whatever that value is. So multiplying both sides by 10. Multiplying both sides by 2 is what we've done here. As long as you're multiplying both sides, you will have equivalent ratios. So that brings us to our summary. Two ratios are equivalent if they both have values that are equal, meaning that structure of your tape diagram will not change, just whatever you're multiplying it by. So again, if I have a 1 to 2 ratio, I can multiply both sides by 2. 1 times 2 is 2. 2 times 2 is 4. Okay, another equivalent ratio, I can multiply both sides by 3. 1 times 3 is 3. 2 times 3 is 6. I can multiply both sides by 4. 1 times 4 is 4. 2 times 4 is 8. Two ratios are equivalent if they both have values that are equal.